Hi everyone, this is Miss Holden, and this is a review of some algebra basics that you should know how to do. So it is assumed in this class that you can solve an equation, and it's also assumed that you can factor. So we're going to review both of those. I want you to try these on your own and then use the video to check them over. If you want to watch a few and then try them, pause the video and then try it, that would be fine. But you should be trying these and making sure that you know how to do this and you remember how to solve equations and you remember how to factor. All right, so the first page is all about solving equations. Remember, to solve an equation, we're undoing each operation. We're basically using the inverse. We're doing the opposite of whatever's there, and we're doing it in the opposite order. So on the first one, I have 4x minus 10 equals 18. I want to get x by itself, so I need to get rid of that 10. So I do the opposite of minus 10 is to add 10. I do that to both sides because it's an equation. I want to keep everything equal. 18 plus 10 is 28. And then I want to get x by itself. This is 4 times x, and the opposite of multiplication is to divide. So I divide both sides by 4, and I get x equals 7. Same thing, number 2. I want to get c by itself, so I subtract 12 from both sides. And I'm left with negative 3c equals 24. I'm trying to get c by itself, so I'm going to divide by negative 3. And I get c equals negative 8. Sorry about the noise in the background. That's my little puppy. 3 has a fraction, which can get a little bit trickier for people. So again, I want to get b by itself. So I'm going to add 9 to both sides. And I have b divided by 3 equals 4. And then to get b by itself, this is division. And the opposite of division is to multiply. So I multiply both sides by 3. And I get b equals 12. Okay. Number 4 gets a little bit different because I have y's on both sides. So I'm going to subtract the 6y that's over on the right. So I bring all the y's to the same side. And then I'm sort of back where I started with before. So I want to get y by itself. I subtract 8. And I have 6y equals negative 18 divided by 6. Y equals negative 3. And 5 I have parentheses, so I need to multiply out. I'm going to use my distributive property. 3 times x is 3x. 3 times negative 5 is negative 15. And then I'm back where I started with, similar to a problem like number 1 and 2. So I'm going to add 15 to both sides. I get 3x equals 39 and divide by 3, x equals 13. And 6 has another fraction. First, I'll get rid of this 6 by subtracting 6 on both sides. So I have negative 5 halves x equals negative 5. And when I have a fraction, I can multiply by the inverse. So let me change the color just so you can see that. So I'm going to multiply both sides by negative 2/5. Because what happens on the left is the 2 and the 5's cancel, and I'm left with the x, and that was my intention. So I get x equals, and then on the right, the 5 and the 5 cancel, and it left with 1, and negative 1 times negative 2 is just positive 2. All right, number 7, I got another fraction going on. First, I'm going to subtract 2 from both sides. And then at the same time, I'm going to use that distributive property. So I'm going to have 5x minus 15 over 8 equals 5. Now, when it looks like this, the easiest thing to do is probably just to throw a 1 under this 5, and I can just cross multiply. So 1 times 5x minus 15 is 5x minus 15, and 8 times 5 is 40. Okay, and then I will add 15 to both sides. And that to get x by itself, I'm going to have to divide by 5, and I'll get x equals 11. And 8, I have distributive property on the left, and I also have distributive property on the right. And I get 4x plus 12. Now I just want to show you, because people get confused on these x's over here, the 5x and the 2x are on the same side. So you're going to combine those together. You're not going to subtract 2x. So everything that's on the same side that can be combined together, those like terms, you're always going to do that first. Now this x is on a different side, so I'm going to subtract 4x, and I hit something, I don't know what I hit, there we go. I'm going to subtract 4x because that's on a different side, and I need to bring it over to the other side. I'm solving for x, so I'm going to add 15 to both sides. 3x equals 27, divide by 3, x equals 9. So everybody should be comfortable solving equations, and hopefully those were okay for you, or at least as soon as you saw them, you're like, oh yeah, I remember how to do that. Now we're going to get into some factoring. So first we're going to talk about the greatest common factor. Okay, the greatest common factor is a number expression that can be divided into each term evenly. It's a number expression that can be undistributed to every term in a problem. So there are two examples right there. Basically what you're going to do, you're going to see what's in common that you can pull out, and you're going to divide that out. All right, so if we're looking at number 1a, look at the 3x squared and the 6x. Is there a common number I can factor out? And there is. There's a 3. Is there a common letter that both of these have? And there is. There's an x. So I'm going to factor out a 3x. Now I'm basically dividing 3x from 3x squared, and I'm just left with x. You can think of it as dividing. And I'm dividing 6x by 3x, which leaves me 2. So this is my answer right here. I could re-multiply it out and get back the original, and that's how you can check to see that everything's okay. So B, again, I want to factor out. So I'm going to factor out a 5 because both these terms are divisible by 5, and I'm going to factor out an x. So when I factor out that 5x, 20x divided by 5x is just 4. The x's cancel. Negative 5 divided by 5 is a negative 1. And x squared divided by x is just x. And then C, 30 and 20, what's a common number that they both have, that they're both divisible by? 10. Now this time it's just the 10 because the 20 doesn't have an x, so I cannot factor out that x. So 30 divided by 10 is 3, and I leave the x squared, and negative 20 divided by 10 is negative 2. All right. And the next kind of factoring is the difference of two perfect squares. Now, what's a perfect square? If we look right here, my perfect squares are numbers like 1, 4, 9, 16, 25, 36. Why are those perfect squares? Because the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. So those are considered perfect squares. And I can even have letters that are perfect squares. X squared, the square root of x squared is just x. All right. Now you can always factor the difference of two perfect squares as conjugate pairs. So basically a conjugate pair means I have a plus and a minus of that same exact term right there. So I have x plus y and x minus y. So it's exactly the same except one's a positive and one's a negative. As soon as you see these, you're going to remember how easy they are. So if we're looking at number 2a, x squared is a perfect square, 9 is a perfect square. So I'm going to set up my two sets of parentheses. X times x is x squared, and 3 times 3 is 9. One's a positive, one's a minus. That's it. Okay. B gets a little bit crazy right off the bat, but it's really just the same exact thing. I'm going to set up my two sets of parentheses. Now, the square root of 4 is 2, the square root of 81 is 9, and the square root of x squared is x. So I'm writing 2 over 9x in the first position for both of these parentheses. And then the square root of 49 is 7, the square root of 9 is 3, and then I'm going to write 7/3 in the second position. One's a plus, one's a minus. It doesn't matter if you write the plus or the minus first. That one was harder. 4x squared minus 25. Set up my two sets of parentheses because they're the difference of two perfect squares. 4x squared, 2x times 2x is 4x squared. 5 times 5 is 25. One's a plus, one's a minus. So these are called the difference of two perfect squares. And then 16 minus 81 x squared. 4 times 4 is 16. 9x times 9x is 81x squared. One's a plus, one's a minus. All right. Now, on the next page, we're going to start off by doing both. First, we're going to do the greatest common factor, and then we'll have to do the difference of two perfect squares, and then we'll get into some trinomials. All right, so number 3, first pull out the greatest common factor. So look at 5x squared minus 20. They both are divisible by 5, so 5 is the greatest common factor. Now, when I factor out a 5, when I divide by 5, I'm going to get x squared minus 4. Now this right here is the difference of two perfect squares. So the 5 is going to be hanging out in front, and I'm going to write my two sets of parentheses. X times x is x squared, 2 times 2 is 4, 1's a plus, 1's a minus, and that's my answer, final answer. B, same thing, try and find the greatest common factor. That's always step 1 in factoring. See if there's a greatest common factor. So 28x squared minus 7. Well, both of these are divisible by 7, so 7 is my greatest common factor. When I divide by 7, I'm left with 4x squared, and 7 divided by 7 is 1. And now this expression in the middle, 4x squared minus 1, is the difference of two perfect squares. So I'm going to set up my two sets of parentheses. 2x times 2x is 2x squared. 1 times 1 is 1. 1's a plus, 1's a minus. And the last one, C, my greatest common factor, 3x cubed minus 48x. They both actually have an x, so don't forget to pull out the x, and they're both divisible by 3. So I'm going to factor out a 3x. That's going to leave me with x squared minus 16, and the x squared minus 16 is the difference of two perfect squares. So the 3x is hanging out in front. I write my two sets of parentheses. X times x is x squared. 4 times 4 is 16. 1's a plus, 1's a minus. All right. Before we get into actually factoring trinomials, let's first practice a little multiplying because the factoring is just working backwards. So number 4, without using your calculator, we want to write each of these products in simplest ax squared plus bx plus c form. So this is actually a trinomial. See that there are 3 terms. So I'm going to do, your teacher might have taught you FOIL, first, outer, inner, last. 3x times 5x is 15x squared. 3x times 7 is 21x. 2 times 5x is 10x. And 2 times 7 is 14. You're always going to get 4 terms. F stands for the first terms, that's the 3x and the 5x. O stands for the outside terms, that's the 3x and the 7. I stands for the inside terms, 2 times 5x, and L stands for the last terms, 2 times 7. You can also just think of it as doing the distributive property twice, but you're always going to get 4 terms, but these 2 middle terms you'll be able to combine together. 21x plus 10x is 31x. And you now have a trinomial in this form, the ax squared plus bx plus c. All right, so if you want, you pause the video, try some of these on your own, and then you can start it up and check to make sure that you got the answer right. So 2x times 2x is 4x squared. 2x times 5 is 10x. Negative 3 times 2x is negative 6x. And negative 3 times 5 is negative 15. So 4x squared, these 2 middle terms I can combine together, and that's my answer. And the last one, 5x times x is 5x squared. 5x times negative 2 is negative 10x. Negative 4 times x is negative 4x. Negative 4 times negative 2 is 8. I have these 2 middle terms that I can combine together. So my answer is 5x squared minus 14x plus 8. So now factoring, I'm working backwards. I'm starting with this trinomial and working back to find out what my 2 factors are. We're going to start off by doing them where the first term is just an x squared. It's not going to have a coefficient in it because that's certainly a lot easier. So I'm going to set up my 2 sets of parentheses. So this is factoring trinomials, this last section right here. X times x is x squared. Now the numbers that go here in the second position, they multiply to give me the 35, and they add or subtract to give me that 2x. So you have to think of the factors of 35. 1 and 35, and actually 5 and 7. Those are my only choices that I have. So which of these combinations, when you add or subtract them, gives me the 2x? Well, that's going to be the 5 and the 7. How are the 5 and 7 going to give me 2x as a middle term if the 7 is positive and the 5 is negative? Okay, because 7 times negative 5 is negative 35, but yet if you were to multiply these insides and these outsides, the 7x and the negative 5x, that would give you a positive 2x. So this is basically my answer right there, x plus 7, x minus 5. So you're playing around with those factors to figure out what the numbers are. So let's try b. I'm going to do b down here so I have a little bit more room. So x times x is x squared. Now I'm thinking of the factors of 24. 1 and 24, 2 and 12. You can write these down. You can think of them in your head. These are my factors of 24. Which of these will give me an 11 as a middle term? Well, the 8 and the 3 will give me an 11 as a middle term. And it would be positive 3 and positive 8. And that's it. That's my answer. C, I have x squared minus 13x plus 22. So my factors of 22 are 1 and 22, or 2 and 11. Which ones are going to give me negative 13? Well, the 2 and 11 will. And in order to give me negative 13, it will have to be negative 2 and negative 11. And when I multiply negative 2 times negative 11, that gives me a positive 22. And then my last one on this page, x times x is x squared. My factors, what numbers multiply to 50? 1 and 50, 2 and 25, 5 and 10, and that's about it. So which of these will give me a negative 5 as a middle term? Well, the 10 and the 5 will give me a negative 5 as a middle term. The only way they'll give me a negative 5, though, if it's negative 10 and positive 5. So when I combine them together, it gives me negative 5 as a middle term. When I multiply them, it gives me negative 50. All right, so let's try two problems of factoring on the next page where the coefficient is not x squared, because that's definitely a little bit trickier, and then we'll try and solve two equations. So when the coefficient is not x squared, but instead I have a number there, you sort of have to play around. It's a little bit trickier with where I'm going to put the numbers. So 3x times x is 3x squared. I'm thinking of the factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Which of those are going to give me positive 19 as a middle term? Here's the tricky part, because it depends where you put the numbers. Whatever number I put in this second position is actually being multiplied by 3. So you're sort of going to have to do a guess and check to see what works. So let me put the numbers in the wrong spot, and then you can see, and then I'll put them in the right spot. So like say I was just checking 8 and 5. Well, 8 times x is 8x, and 5 times 3 is 15x. Can 15 and 8x ever give me a 19x? No. Well, look what happens if I try the numbers in the opposite spot. If this is 5 and this is 8. Well, 5 times x is 5x. 8 times 3 is 24x. Can 5x and 24x ever give me 19x? Absolutely, if it's a positive 24 and a negative 5. So this would have to be a positive 8 and a negative 5. So it's super important when you have a number, a leading coefficient, that whatever number you put in this second position is actually multiplied by that coefficient in front. So you have to be careful. But this is my answer right here. So you're really just using a guess and check to figure it out. So try this one. 2x times x is 2x squared. Now I'm thinking of my factors of 18. And the more factors you have, the more you just have to play around with it. So I'm basically saying, all right, 1 and 18 is probably not. 2 and 9. Well, if I put the 2 here and the 9 here, That gives me 2x and 18x. Can 2x and 18x ever give me negative 15? No. Well, let's try the 9 here and the 2 here. Well, that gives me 9x and 4x. Can 9x and 4x give me a negative 15? No. So let's try the other numbers. So now I'm going to try 3 and 6. If I put the 3 here, I get 3x. If I put the 6 here, I get 12x. Can 12x and 3x ever give me negative 15? Yeah. In fact, if it's, let me just change the sign here. If it's, what was it, 12x and 3x, the way they're going to give you 15 is if it's a negative 12x and a negative 3x. So this is negative and this is negative. So I'm just guessing and checking. Now back in algebra, you also solved quadratic equations. So the first step, here's a list of rules. First step, you have to get it in standard form and you have to set it equal to 0. Second step, you factor if possible. Then you set each factor equal to 0, and then I solve the resulting equations for the variables. So let's look at number 7a. So everything has to be on one side. So I'm going to add 2x, and I'm going to subtract 10. So I'm going to add 2x, subtract 10. That gives me x squared plus 5x minus 24 equals 0. So step 1, get everything on one side. Step 2, factor. All right, so I'm going to set up my parentheses. This is a trinomial. X times x is x squared. What are my factors of 24? If it helps to write them down, write them down. See if any of these factors will give you a 5 as a middle term. Absolutely, the 3 and 8. The only way the 3 and the 8 are going to give me 5 as a middle term if it's positive 8 and negative 3. And then I take each of these factors and I split it up and I set each factor equal to 0. And the only thing that does is that it changes the sign of the answer. Because I'm going to have to do the opposite. I'm solving the equations that are resulting. And I get 2 answers. And those are my 2 answers there. All right, so if you want to pause the video and try B, you can. I'm going to subtract x squared, subtract 3x, and add 2 because I need everything on one side. I'm going to subtract x squared, subtract 3x, and add 2. That gives me 2x squared plus 9x minus 5. So everything's on one side. Now this one I have a coefficient. Those are always a little bit tougher, but it's just 2, so that's not too bad. And I'm thinking, what are my factors of 5? Actually, this is not bad at all because there's only one possibility that will work, 1 and 5. It's just a matter of where you're going to put the 1 and the 5. Well, let's try 1, 5. Test it out. This gives me a 1x and this gives me a 10x. Can 1x and 10x give me a positive 9? Absolutely, if this is a positive 10x and a negative 1x. Remember, this is a 5, but it's being multiplied by 2. Once you have your factors, then you just take each factor and set it equal to 0 and solve. So I get x equals negative 5 and x equals 1/2. All right, so that's a review of some basic stuff that you should have learned in Algebra 1 and that you should be comfortable with. And hopefully you were.